I think we can move along now, and let's get started. Today's webinar, excuse me, is from Healthchecks to real-time metrics, Clever's journey. And today's webinar is sponsored by our friends at SignalFx, and we're happy for their sponsorship and happy to be joined by two great panelists today. First, we have Mohit Gupta, who's the product and engineering lead for infrastructure at Clever. And Mohit, just quick sound check, making sure you're there and all is well. Thank you. Mohit, you there?
Yeah.
Perfect. And joining Mohit and myself is John Bruce, head of solution engineering at SignalFx. John, welcome to our webinar today.
Thanks very much. Glad to be here.
Okay. So before we head things, before I turn things over and we dive into the presentation, I did have two polling questions that I wanted to ask our audience, which I think will help guide our discussion today and give all of us a little bit of information about where we are in our own journeys. So with that said, I'm going to ask our first question. And Jules, if we could put it up here, and it's, are you using a public cloud provider today? And you can choose more than one if you're using more than one. Or if you're not using one, if you would be so kind as to choose not using one. Interesting. It'll be interesting to see what our audience is actually doing. So if you could just choose one of those, shouldn't be too hard. We'll close things off in 5, 4, 3, 2, 1. Okay, and the survey says, well, that's actually pretty surprising. So I don't think anyone is surprised that AWS is sort of the 800-pound gorilla in public cloud, and fully 44% of you are on AWS. Azure was probably a little low at 6% than what we've seen. But I think the surprising one here is not using a cloud provider, period, which equals, really funny, equals AWS. So that's probably a little higher than we've seen in past polls, but very interesting indeed. Why don't we go to our next question if we can, Jules? And that is, how large is your infrastructure? And in today's world, of course, we can't just talk about servers, we talk about instances and everything else. So we say 1 to 50 instances or VMs/servers, and that's kind of the metric we're using. So is it 1 to 50, 51 to 100, 100, 500, etc.? And again, if you can answer this, and we'll close questioning off in just about 5, 4, 3, 2, 1. Okay, and answers are, so this is, I think, in line with responses we've seen to this type of question before. It really is amazing. Someone who is old as I am, and I come from a day when we were racking servers in mount racking servers, and the idea of racking up 1,000 servers would boggle my mind. But in the world of virtual machines and containers and so forth, having 1,000+ servers is no big deal, I guess. And fully 37% of you, as you can see here, have 1,000+. Interestingly, the next biggest segment is just the 1 to 50s. So with that information in mind, let's move on. And I'm going to turn things over now to our presenters. And I believe, is it John who's, no, it's Mohit who will be going first, correct?
That is correct.
Okay, Mohit, I'm passing the football to you and looking forward to hearing your presentation.
Thank you. Hi, is my voice working out? Is this?
Yes, that sounds great.
Cool, thanks. So I guess I'm going to be talking about the journey of Clever to where we got in terms of metrics and alerting. And I guess I should say Clever is kind of a single sign-on and account provisioning tool that is used by more than a third of public schools in the US right now, and to connect to over 250 different apps. So you can think of it in one way like Facebook Connect for schools, with of course a very, very strong focus on control and privacy, where the graph, instead of being the social graph, is kind of like what schools and what classrooms are teachers and students interacting in. So with that context, it's really, really important for us that we know what is going on in our systems, because if our systems are down, or even if a certain school can't log in at a certain given point, their entire classroom is missed. So from the very beginning, it became very clear that we had to know our systems really, really well. And so we kind of started experimenting with various ways of alerting and metrics. And I'm going to kind of go over what our current beliefs are, like what do metrics mean for Clever, and how we think about types of alerting. We have a very strong focus. My team, the infrastructure team, has a very strong focus that every engineer should be able to decide what metrics are best for them, and control that on both edges. So when they're creating them, and also when they want to figure out what to do with them, without caring at all about how they get shipped, how they get transformed and routed, or how you scale the pipeline for that. So I'm going to talk about some of the tools that we use for that, and then a very short deep dive into how the pipeline in the backend works that my team maintains, and kind of close out with some of the things that we've seen. If you build things the way that we've built, what are kind of like the challenges that we are currently facing, and also what are some of the things that we got for free, which have been very exciting. So I'll dive in into what we think of as metrics right now. So the first idea is, when you're collecting a metric, whose concern should it be and what the responsibilities should be. So I think I went into this a little bit. An engineer decides, what are the metrics I need to collect, why, how often they should be collected, and they need to have some understanding of the limits of our pipeline, but we've tried to make sure, as we've grown, to make that more and more automated. So like an engineer can just be like, I really care about this in my app, and if their app scales up to a level where they're collecting data that is not manageable for real-time graphing that they want to do with it, we'll alert them that they need to change the way they're doing things. Which means that in classic 12-factor app way, our infrastructure provides some tooling so that they can use in the app that they're collecting. We deploy solely on Docker containers, so that means that we provide this tooling for multiple languages as libraries. But from the very beginning, the infrastructure has been responsible for collecting the logs, so the apps kind of just communicate over standard out and standard error. They don't have a special logging network library or anything like that, because as we've scaled, we've changed those pipelines continuously. And the other things are, basically, we take them, we ship them to places, we route them into various places, and also want to make sure if anything goes wrong, like the engineer doesn't have to worry about it. This is, I think, very important, and maybe a lot of you have already run into it. We focus purely on push-based metrics. The traditional way to do this is, pull, where it's hard to know what things to connect to. So for us, what happens is an app starts up, and then we will push the metrics through our pipeline. rather than some central place which knows all the places to collect metrics from. So this is kind of like the Nagios model where you ping different servers. But in our infrastructure, the servers are changing like every given second, so we can never keep like a complete state of all the things that might be starting or stopping or in progress. So we kind of try to keep, it's the responsibility of every app that gets launched, the infrastructure makes sure that we are pulling metrics out of it. This is something that we've changed maybe like a year and a half ago. We used to go with dot separated nodes or the graphite style, if some of you have been aware of it, and we've moved completely into key value pairs. I'm going to talk about some of the benefits of this, but basically we moved away from a hierarchical model into a completely free-form key value model so that we can decide later what to index, how to aggregate, and don't have to worry about hierarchies. So how do engineers interact with this? First is we've built a bunch of libraries in various languages called KV. These languages allow you to write logs and also metrics. So basically, it's a structured logging library that has specific support for gauges and counters. We've written them in 3 languages that are used very widely at Clever, which is JavaScript, Go, Python. I guess we have both a Coffee and a JavaScript version for Node. And this is basically something that we internally have a test that everything that gets deployed should use this package. And if it doesn't, like something is wrong. We can change the backends for this pretty easily, but right now it just goes to standard out. We use, so engineers also use Grafana to, they might, as you can see here, they might just start measuring something and immediately they'll be able to see what their metrics are from our Grafana dashboards. We also use SignalFx for mostly very, very highly customized composite metrics. So here you can see one example of how we compute job error rates. So we are basically looking at the percentage and the kind of percentile error. If it is above a certain threshold, only then do we want to alert. So these are a lot of back-end jobs that they fail once or twice and it's fine. But if the rate increases, then we want to know before our users tell us. So one of the things that has been really exciting in all of this is basically engineers are deciding what metrics to use, and then all of the processing is done on the very end when they're trying to figure out what to do with it. So we keep most of the raw data through the entire pipeline. So what does that look like? I'm going to go through this pretty quickly and hope that if people are interested, they'll ask me questions. So generally, you have a source, which is where the logs and metrics are coming from. We have an aggregator, a router, which I'll explain a little bit, and then sinks, which is where the data ends up. So our infrastructure team manages, we use rsyslog for shipping all logs and metrics. Again, this is something that is a decision we make early on that has been working very well for us and is kind of different from how a lot of people do this. We also aggregate using rsyslog in a server mode that we scale out. We use Heka, which is a Mozilla product, open source product, which for routing. And then we have some special things that we've built. One of them is called Signal Me Maybe, which basically takes alerts from SignalFx and does automated management of our infrastructure. So if something goes wrong and we know how to fix it, we'll just get the alert back and then make the fix automatically without telling an engineer about it. So what are engineers doing? They're deploying Docker. They sometimes are deploying processes. They also sometimes use Diamond to collect like custom metrics about network throughput and things like that. They can push configuration into the router, and I'm going to focus a little bit on the router. But here are some of the things that we use already. So we use Elasticsearch. We send data to SignalFx. We send data to Grafana via InfluxDB right now. and then we send data to Redshift for analytics. So we also want to do long-term analysis on our engineering metrics, and many times we'll send some things to because it's something that happened which is very exciting or very scary. So how do we make sure that all of these, a single line that was emitted in an app somewhere goes to all of these places? And that's the job of the routers. So behind the scenes, what happens is that we parse every single log, and we have a ton of parsers into structured data. We push them to a cluster of RabbitMQ queues, and then we have a lot of different outputs, which are just kind of like custom written Go code, which can interact with different kinds of services, and it pulls out of this queue the kind of things that it needs to send to certain places. So these are the parts where the engineers can decide and push config to say, you know what, I made this new metric, I've been looking at it in short-term metrics on Grafana. I really think that we should keep this metric in Redshift because I want to do like month-over-month or year-over-year analysis. And all they do is that they push a change which they say, okay, now send this metric to Redshift also. So that has been really powerful. So a quick look into what we are doing right now. The first is this pipeline is currently handling about 10,000 events per second, and we have a jitter of about 8 seconds sometimes. So which means that a metric may have plus minus 8 seconds before it reaches the sink. And at the current scale, that jitter is something we are not happy with. So we are working on reducing that by measuring all the different parts of the pipeline. We've had cases where certain apps emitted too many metrics, and that caused other apps to get affected. And so we are building a lot more guardrails around that. We are also working on some exciting stuff around sampling of metrics so that we can tell engineers before they even push a metric fully into production what kind of load it is going to create for our infrastructure. Of course, KV is getting lots of work for having middleware hooks to kind of APIs so that we can standardize those logs, and we are working on that a lot. We have some prototypes for UIs for the custom routing of metrics so that you can just like select the ones that you want to send to which places. We've had problems with high dimensionality, which means kind of like if we are keeping a session ID, there are certain data stores that don't work very well with millions and millions of dimensions, kind of like session ID. And part of the sampling work is to make sure that we can warn engineers beforehand that their metric is not going to go very well if they select a certain sync. And of course, this year we are expecting about 50,000 events per second. So we are working a lot on horizontally scaling all the different components independently. We now run all of this on a Mesos cluster so that they auto scale up and down based on how many metrics are being pumped into different parts. And we also are working a lot to kind of have dynamic fields that get aggregated automatically. So which means that for aggregations, you need to know what kind of metrics you're going to be querying beforehand. But one of the things that we're working on is to backfill. Once somebody decides a certain aggregation is good for them, we go into some of the long-term storage and then kind of figure out what kind of aggregations I should start building even for the past. And that's it from me. Thanks. We write a blog at engineering.clever.com, and we are hiring in many positions. Most of this stuff is also open source, by the way, so please, you can check out our GitHub, and we release almost all of the tooling. Thank you so much.
Thank you, Mohit. That was excellent. I think we're getting okay. Okay. Before we, I think we're getting a little echo. Perhaps Mohit, or on the back end, can you mute? Thank you. All right, before we move on to our next presenter, we do have another poll question that we'd like to answer in here. Jules, perhaps if you can pop up the question. So after listening to Mohit, let's talk a little bit about how do you do your monitoring today? And again, hopefully you can choose more than one, choose all that apply. I know with the public cloud question, some of our listeners said that you can only choose one. So how do you do your monitoring today? Health checks like Nagios, do you do it yourself, metrics, hosted metrics, APM or others? And if you can respond, we'll give it another 5 seconds. 5, 4, 3, 2, 1. And let's see what our audience says. Well, health checks took 72%, do it yourselves at 30%, APMs like New Relic at 33%, and hosted metrics such as SignalFx. Actually, the biggest, or the second biggest, was other. I'd love to see what some of those others look like, but just for another webinar and another day. With that being said, I would imagine over time we'll see more of the SaaS-based or hosted metrics really start to come on in the market. And with that being said, let me introduce John Bruce. John, as you probably saw on his background, an entrepreneur and leader in the SaaS and enterprise software space. He's been at Signal. John is the head of solution engineering, where he's heavily focused on sales engineering, product development, consumer input. John, if you're there? Yes?
I am indeed.
Okay, before I hand it over to John, just a quick reminder as well to our audience. We do have the question section in your GoToWebinar control panel, and we do have time, hopefully, for questions at the end of John's presentation and demo. So please put your questions in there in real time. They'll be saved, I promise you, and we'll get to them later. That being said, John, it's all yours.
All right. Well, hey, thank you again. You know, I'm happy to be here alongside Mohit from Clever, and I'm excited about what we're going to walk through today. So, you know, just by way of introduction, I guess you already did it, but you know, John Bruce, I do run solution engineering here at SignalFx, and what I wanted to do is walk through a little bit about SignalFx. We are a monitoring tool set for modern infrastructure. And then we'll jump into a live demo. So for a lot of you guys in the room, or on this webinar I should say, this is probably old news, but we're experiencing a shift from monolithic scale-up applications that are built out on enterprise-grade hardware, and we're moving over into this world where there's more and more application-centric development practices, potentially microservices behind those applications, a number of VMs, as we saw from that survey earlier, and environments that are potentially elastic, so they scale up, scale down at a moment's notice, and very ephemeral. So what does that mean for reporting? And I think you know, you guys have probably seen this in your day-to-day, especially if you were ones that answered yes to the cloud provider question. Host-specific alerts begin to generate noise. You have this kind of challenge of my existing monitoring might be a little bit noisy, it might be a little bit reactive. If one of my hosts goes down, do I care? Does that actually matter? Was it supposed to go down as part of a scale back, or is there something actually wrong? How do we begin to figure this out? And more importantly, we do still need this centralized view. So a really good example would be, hey, maybe 2/3 of my machines are down, right? So your capacity is down to 1/3 of what it might have been, but your load on the actual application, the number of users passing through that application, has actually doubled. How do you begin to correlate and actually alert? Because more than likely you're going to want to know when that's happening so that you can take action and you can begin to do whatever you need to do on your side to address this particular situation. You want to be alerted. And the way that you're able to do that with a system like SignalFx is we allow you to build actionable and timely alerts. This is a little bit of an eye chart, but specifically the 83% line, that's a static threshold. I think a lot of people are used to alerting off of, just some arbitrary threshold that you set. You might see, okay, this threshold is triggering some alerts, maybe I need to reset it, and that just becomes an ongoing process for how you manage how you alert. In the SignalFx world, what you're seeing is with that static threshold, you might be triggering or flapping alert every now and then, and maybe that just becomes noise after a while. You begin to ignore it because it's that kind of the boy who cried wolf, so to speak, that just keeps going. But what we're doing is saying, hey, you could actually create an alert on something like the growth rate, and trigger at an inflection point for that growth rate to actually give you time to come in and fix whatever is happening in your system. So for example, Elasticsearch. I know a lot of people out there using Elasticsearch for indexing metadata. We are internally at SignalFx. If your Elasticsearch clusters are starting to run out of hard drive space, and you miss effectively the cutoff window before you need to come in and actually reshard your Elasticsearch servers individually, you're actually going to have some downtime. So if we can help you predictively show you that these servers are going to run out based off of growth rates earlier than you might otherwise be able to see with a flappy alert based off of a static threshold, we think that that's a win-win. And furthermore, we're going to help you use analytics to calculate any number of different fairly advanced metrics inside of your system that are going to give you new insights into the way that your systems are operating. And this is the obligatory logo slide. These are all of the open source products that we integrate with today, as well as all of the Amazon services that we integrate with today. And the point behind this is that we give you the ability to very, very easily monitor any of the services in that list with pre-built content, pre-built dashboards, pre-built charts, and pre-built alerts, so that we take the work out of having to set this up for yourself from scratch, and make it much, much easier to get up and going with SignalFx. And finally, just at a high level, SignalFx is your solution for getting business metrics and events, user metrics and events, app metrics and events, and system metrics and events into a single area where you're able to leverage the benefits of Signalflow, which is our analytics engine, to give you real-time visibility and correlation across your entire stack. We have resolution down to 1 second, so you can actually monitor what's happening across all of your systems at a resolution all the way down to literally every second. And as I mentioned earlier, all of this comes with pre-built integrations and content that are going to flow through to actionable real-time alerting. So with that, I'm going to jump out of slides here and jump into an actual demonstration of the product. So at this point, we're now inside of SignalFx, and this is one of those pre-built dashboards I was talking about that's specifically going to deal with infrastructure. So as you can see here, at a glance in my dashboard, I can see all of the services that I'm running. I can see all of the hosts that are inside of my ecosystem at this point. And I have a number of different charts and analytics that are being automatically built for me based off of my environment. I can see the active hosts that are in my environment at this point in time, especially interesting in those Elastic environments, I think, because this will change over time. We're able to use analytics to give you very powerful aggregations. So you can see here that when I hover over this chart, we're actually plotting the max, the 90th percentile, median, 10th percentile, and minimum. All of these are being calculated in real time off of your metrics as they come into our platform. So these are not being calculated by our agent or by a client. They're being calculated by our analytics pipeline on your streaming data in real time. You'll notice too that we have built-in analytics and detectors to help you understand which of your hosts have died, let's say in the past 24 hours or maybe the past week. And I had mentioned earlier with my Elasticsearch example, this notion of the fact that we can give you these predictive metrics in this particular case, if we look at, say, the number of days left based on disk space, what we're doing is calculating the amount of disk that you're using over time, so what that growth rate is, and we're forecasting that out and actually telling you that if this keeps up, if nothing changes, you're going to run out of disk space on your MongoDB instance in about 9.3 days. So all of this, again, is here for you at your fingertips. And I want to come back to the alerting, which this is, you're getting this out of the box. This is visualization. Now, we have a number of these key alerts that we've created for you automatically. One of them that's particularly interesting, let's say, is my dead host detector. Are my hosts up or down? Adding yourself to a detector in SignalFx is actually very easy. I can come in, I can open up the detector itself. In this particular case, I have created this detector, or the system has created this detector off of pre-built content. But if you were to create it by yourself, you can create it step by step using our analytics engine. And then finally, you can come in, you can name your detector, set the severity, you can alert if above, below, out of range, or in this particular case, within range of a static or potentially a relative value. I can trigger after a duration of time to avoid flapping. Even after a percentage of duration, if I wanted to say 100% of 1 hour, this is going to look at a 1 hour window, and if during that 1 hour period of time, more than 50% of that window, doesn't have to be contiguous, was spent in this condition, it will then and only then trigger this alert. And it's very, very easy to subscribe yourself to these notifications. So if I come back in, I can add myself, my email address. We can also alert out into HipChat, PagerDuty, Slack, VictorOps, arbitrary email addresses, as well as webhooks. So let's say that I want to send this into one of my Slack rooms, and then maybe I also want to take a look at how the webhooks work. So if you have these alerts set up and you want to trigger auto remediation on your back end, or maybe auto scaling on your back end, you can listen to this webhook notification and kick off any processes on your side that you would need to based off of what's happening in your systems at that point in time. And once I've subscribed to the alert, I can go ahead and save this. Now I'm done, I'm good to go, and I'm going to be alerted anytime any of my hosts in my infrastructure go down unexpectedly. And taking this sort of to the back to the basics, as it were, it's very easy to get an entire host list, and we're pulling a lot of metadata for you automatically if you're in Amazon or using our agent, which is CollectD. Many of you have probably heard of CollectD. It's an open source project. We actively contribute. So anything that you're running on your servers is going to be open source. So you're going to know exactly what you're getting, and it is a proven, tried and true product in the open source community. So you've got all of your information about your hosts here at a glance. If you're using Amazon, we can give you Amazon-specific visualizations, meaning all of the data coming in from CloudWatch. We can integrate that and pull that into the SignalFx platform as a starting point with a simple click of basically adding your role into SignalFx, setting what you want to pull, the pull rate, and saving that. Once you've done that and set up that integration, we're going to give you all of this visualization both about your EC2 instances, but also about all of the, what I like to call black box Amazon services or AWS services, such as SQS, SNS, EBS, services where you can't actually install an agent on it and you have to rely on that CloudWatch data. You're going to be able to visualize that data, alert off of that data, and because SignalFx is a multi-dimensional platform, I can come in and start to use the tags that Amazon is providing us, as well as any custom tags you've created on your EC2 instances to begin to filter these dashboards in real time. So in this particular instance, I'm now in Amazon Availability Zone US 1 East, and maybe I want to continue to filter down further based off of, again, any of these Amazon tags. And furthermore, if you've enabled Amazon and you're using our agent, you're going to get the benefit of the fact that you can see these Amazon tags can now be used to filter collectee data as well automatically, because we're doing that mapping for you behind the scenes. Just to be clear, you do not need to be on Amazon Web Services in order to use our agent collectee. So if you're on bare metal, if you're on an alternative cloud provider, you can still use our agent, get 1 second resolution data all visualized here, and benefit from the fact that collectee has a very healthy ecosystem of different open source plugins and solutions out there that you're going to benefit from out of the box. So I started this talk talking specifically about pre-built content. If you're using collectee, and let's say, for example, you're wanting to monitor Memcache, or maybe you're wanting to monitor Docker, I can come in and I can actually look at my entire Docker ecosystem. So in this particular case, we're able to come in and show you that across all of your hosts, right, we can give you the number of containers per host. We can give you your entire host count across all, your entire container account across all hosts in your Docker ecosystem. Give you all of the stats that you might think about aggregated across all of your Docker hosts. But what's really interesting is when you start to drill down. Let's say that I'm very interested in Docker, and what I want to do next is I want to drill down into a specific host. So in this case, I can come over here on the left. I can drill into one of my hosts, and now I'm presented with A, the infrastructure metrics for this particular host that are being pulled in by collectee, B, a process list that's actually sortable in real time here, as you can see as I'm updating this on the fly, and C, I can see what this particular host is doing by way of the Docker containers that we see on this host. So I can come in, and if I highlight this chart, you can see I've got all of these different containers, and I can see the CPU usage per container. And if I was really interested in whatever this container is here, this looks to be the MongoDB 2.6 Docker container. Well, let's go ahead and drill down one more time into that particular Docker container. And now I can see that once I'm inside of that container, I can see the CPU usage, memory usage, etc. And again, this is just one of the many pre-built dashboards that we have based off of the open source technologies that you're used to seeing. So again, Cassandra, Elasticsearch, Kafka, Memcache, Mongo, Nginx, Postgres, a number of queuing platforms, RabbitMQ, ActiveMQ, Redis, caching systems like Varnish, and also Zookeeper. So this list is growing, let's call it, with every release as we begin to add into this plugin ecosystem and continue to standardize around the integrations that we can give you today. And where I want to finish up is I've showed you a lot of pre-built content, showed you a lot of pre-built alerts. So when your alerts are firing, you're going to have a dashboard where you can actually come in, see all of your alerts are firing at any given time, sorted by severity, and you can pull up and drill into any of your alerts from here to actually do discovery into what specifically is going on. And furthermore, our system does also track events. And so what I mean by that is if we're back inside of a dashboard, let's this time go into maybe Memcached. We have an events feed in the platform that you can actually map onto individual charts or dashboards such that you can correlate things like a release. You can correlate things like a new feature release, a code release, a rollback with all of the metrics data that you're getting in the platform today. And where I'd like to end up is I'm going to go into just my home page here. You can see all of the alerts I was talking about on the side here. This is our alerts feed. But what I really want to do is end with the creation of a chart to show you just how easy and how powerful the system is for creating charts in real time. So I'm going to go ahead and pull up a transaction count. So in this particular instance, you can see how fast that was. We've got 18 different time series we're looking at right now. Maybe I want to narrow this down by only my Paris data centers, for example. So this is, again, going to filter down in real time. I can begin to add analytics to this particular chart. So maybe what I want to do is I want to sum this transaction count across just my data center in Paris. So we'll go ahead and do an aggregation here. And then maybe what I want to do is actually add a moving average. So let's do a 30-minute moving average here. And now what I want to do is I want to begin to calculate a growth rate. So I can come in, I can clone this particular signal. We have a time shift function in the platform. So I know Mohit talked about time shifting a little bit, and they're potentially doing that in Redshift today. You can actually do that inside of the SignalFx platform as well. You can do it on arbitrary time periods. So I could do a week. I could also just as easily do 37 seconds. So I'm going to time shift this by a week, and now you have two signals, one for right now, one for a week ago. And then I'm going to use our expression builder here to come in and add a naive growth rate. So A divided by B minus 1. Again, I did mention it was naive. I'm going to go ahead and hide the two signals that I used to build this. We have a scale function in the platform, so because this is now a percentage, I'm going to go ahead and scale it by 100% or 100. And now we've got our growth rate percentage and how that's changing over time. I can come in, I can change a number of different things about this particular chart. Maybe I want to turn this into an area graph above and below 0. So growth rate above, or basically a declining growth rate. The other thing that I could do is maybe I actually want to take this signal here, and now we're really getting into the details, but I want to actually calculate the mean plus 3 sigma. And I can do that over maybe a 1-hour rolling window. And now I have this threshold that potentially now I want to alert against this threshold. So that would give me the ability to say that my growth rate, if I take the average of that growth rate plus 3 standard deviations above the mean, maybe that's something where if my growth rate surpasses that dynamic value, I want to alert, because that means that regardless of any kind of seasonality, regardless of anything that's happening in my data, right now, at this very point, my growth rate is growing abnormally fast for where it should be. So this is, again, a high-level overview from the pre-built content, the infrastructure alerting, host up, host down that we can give you, all the way into the power user functionality, where you can go in, build your own charts using very sophisticated analytics that are updating in real time. So I'm going to go ahead and wrap up now, but for everyone on, thank you very much for your time, and please don't hesitate to ask any questions about what you've seen today.
Great. John, excuse me, before we go on and we get to questions from the audience, I have 2 more questions for the audience. And Jules, if you can jump. Okay. So currently, at what level do most of you do your monitoring? Is it the host or individual system, cluster, app level, user level, or if you don't know, that's cool too. If you can give us your answers in 5, 4, 3, 2, 1. Jules answers, so, well, the biggest percentage is at the application level. I guess that makes sense in today's app-driven world. And as you can see, host or individual, system level, and don't know come in next. Final question that we're going to ask for you. Do you do any kind of analytics or aggregations on metrics before you alert on them today? And this is really a yes or no question. Shouldn't be too hard, and we'll close questions down in 5, 4, 3, 2, 1. Answer, well, 57% do not. I guess that was probably to be expected. All right, let's see if we can get to some of our questions now. First question I have is from Mohit. Mohit, if you're there. How hard was it to get your engineers? Okay. How hard was it to get your engineers to understand how to use metrics and analytics for alerting?
I think the way that has, so we've tried many things. Of course, it's not always straightforward, and some people love it and others have like take a little time to kind of get up to speed on analytics-based alerting, what has worked best for us, and I think we do that very actively now, is to show people how far they can go. Let me step back a little bit. The first step that we've done is that we just let people collect metrics and have them not worry about what to do with it. As an app engineer, just, what do you want to know? Just collect it. You don't have to run analytics on that, nothing. And you can look at it right away. So I think that builds a lot of empathy for every engineer, because they're curious. The second thing we have is that we have these things called intra-office hours, where once they start looking at metrics, they have questions. In those question sessions is where, like, usually we will come up with the analytics. And from my experience, once somebody gets a taste of using percentages and time shifts and standard deviations, it spreads pretty fast. So it took some back and forth, but I think with a combination of making it extremely easy and no constraints on an engineer to collect a new metric and look at it immediately. And the second one is to give them support to answer their questions about that metric that they are now looking at, is what has worked for us.
Excellent. Mohit, one other question. What kind of things do engineers alert on?
Sure, that's everything. So some of the things that I did not talk about is that we at Clever focus very much on, we have two kinds of alerts, which we call like page alerts or anomaly alerts. The one way of understanding is that we try to do user-focused alerts, which is basically alert on something that the user will care about. And the other kinds of alerts are cause-based alerts, which is alert on something that has gone wrong in your app or your infrastructure, but the user may or may not know about it. So those are usually the causes for the user's pain. In our case, I think most people will do a lot of user alerts. One is because we train people to do that. They're the highest, highest value alerts. If we know before, as soon as a user is having some trouble, that is what we really, really want to do. And then it also forces people to get into cause-based alerts that are more useful for them to dig into. So basic examples, we alert a lot on request percentiles and sharp increases or decreases around that. So if request times are suddenly increasing or the 99th percentile is suddenly increasing, most of our systems actually alert on any single 500. So if there is any server error that is returned to the user, that fires a loud anomaly alert. And most of our teams have a focus of having 0 of them week over week. And a lot of the different kinds of alerts, one of them which I showed, which is kind of hard to explain in a short conversation, is a lot of it is around things that don't matter immediately, but if rates or the second order rates of them change, then we really, really need to know. So those are, most of Clever is doing lots and lots of back-end processing for cleaning up data, and that's I think a big part of our alerting and benefit of analytics is that.
Got it. Okay, our next question, I think is for John. Can the analytics fetch metrics of applications like GitHub, Jira, TeamCity?
Yeah, Alan, hey, thanks for the question. And actually, I want to chime in on the last question as well, because we have a lot of customers that are using our platform, and we're able to see the metrics that are coming through and sort of the types of metrics. And we kind of see a breakdown between infrastructure metrics, what we would call application level metrics. So an infrastructure metric is obviously going to be a CPU metric, a memory metric, an I/O disk, something like that. The application level metric is going to be something along the lines of, for my application or potentially for my service, if we're in a microservice environment, how many requests have come through this service, what is the latency of the calls that are going through the service, and usually tying that pretty heavily into the dimensionality of our platform, meaning we can actually begin to segment that by, where was it coming from, what data center, you name your segmentation that you're looking for on your end, and you can create a dimension for that in the SignalFx platform to be able to filter your data on. And the third type, this sort of higher level metrics would be the business metrics that we see. So in some cases, if you have a system like a bidded system or a real-time system that actually ties into revenue, you can actually correlate revenue with your application metrics and with your infrastructure metrics. So you could say, when my app starts to slow down, when users are not able to log in, it actually corresponds and correlates in this way to my revenues. So we have customers across the board with those metric types. And then to answer the actual question that was posed to me, you can take any of that data into the system, and in fact, we actually have Git hash. Our engineers push the Git hash as a dimension onto a number of different metrics in our platform today so that we can do canary pushes or canary deployments effectively and monitor how the canary is doing, what the latency is, what's actually going on with that particular version of the code versus the stable version of the code that's already been released. So, GitHub, you could potentially use their webhooks to call out to us and even push events into our platform. So if you have a CI/CD type of environment going, you could commit to GitHub. You could use a webhook in GitHub to push an event out to us, such that you could kind of have a very automated way of then understanding that new code is out there, it's been deployed, let's monitor that, and really alert on this, hopefully, because we can do it in real time before your customers know anything's wrong.
Excellent. Got a few more here. Do you build custom hooks and plugins?
I think I'd need a little bit of clarification around the question, but we do have we have a fully public API that you can use the API to push both metrics and events into our platform, and you can also pull data out of our platform as well. We had one of our customers, Stormpath, actually use Lambda to create a process whereby they were able to send SignalFx notifications into Lambda. Lambda would process them and do something else with them on their end. So I don't know if that completely answers the question, but again, with the API and with the webhooks, you should be able to build any of those things. And as I mentioned, we are active contributors on the development side to CollectD and a number of the different CollectD plugins. So we're building more plugins for different open source services and technologies as the market demands them.
Okay. I think we only have time for maybe one more question. And John, this one's a mouthful, and without being too overtly supportive of SignalFx, but one of our readers wants to know, how are you different than, let's say, an AppDynamics or a Splunk?
Yeah, no, that's a great question, actually. So realistically, we can sit side by side with both of those systems because we recognize that there is a place for APM and there is a place for logging and there is a place for metrics. So if we were kind of imagine a left to right progression, on the left-hand side you have something like a New Relic or an APM type of platform. And I don't have this slide up, but we had an analogy going for a while that basically said that application performance management is, to use an airplane analogy, kind of the pre-flight checks that you're doing before your plane is in the air. You're able to really understand the stack traces and the errors that are coming out of your code, and you can do all of this kind of before your flight takes off, right? And then when you're in the air, that's SignalFx. So we're your real-time telemetry gauges, and SignalFx is your flight computer that's taking all of this data and really only surfacing the things to you that matter to you about what's happening to your airplane right now in real time. And Splunk is effectively more akin to a black box. So, you know, if something happens, I need to be able to drill down and do a forensic analysis of where things went wrong, what happened, and actually figure out, you know, on line 1,275 of this particular log that pertained to this particular service, this is where we were able to finally get to an RCA. So we do have an integration with New Relic and AppDynamics, incidentally, so we can take both of those products and pull information from those products into our platform. And we're also able to tail log files and pull metrics out based off of regular expressions. So we can get some of that information into our platform, but there is going to be really no substitute for the depth and detail that you're going to get in a log file in a program like Splunk, and some of the code errors and tracing that you're going to get with a bytecode inspection agent like a New Relic or an AppDynamics.
Excellent. And John, that was an excellent question to end things, but we're at the top of the hour and we are mindful of people's time. So John and Mohit, thank you so much for appearing here today and presenting. I think it was great. Thank you very much for SignalFx for sponsoring today's webinar. Most of all, thank you to everyone who stayed on here till the bitter end, to the end of the webinar. We will have slides available and a recording of this available. This is Alan Schimmel, Editor-in-Chief, DevOps.com. Look forward to seeing you on another DevOps.com webinar, everyone.